To find the surface area of a sphere, we're going to first start with the formula for the area of a circle. The area of a circle is pi times r squared. And the surface area of a sphere is going to be bigger than the area of a circle. In fact, it's going to be exactly 4 times bigger. So the formula for the surface area of a sphere is 4 times pi times r squared. The volume of a sphere is a little trickier. In order to get to the third dimension, in order to get to volume, we're going to have to take the radius and cube it. And we're going to still multiply it by pi. But we're going to also multiply it by 4/3. This 4/3 is actually developed through calculus. And I'll let your calculus teacher explain where this 4/3 comes from. If we look at example 1, we have a sphere with a measurement all the way across the sphere of 5. So the first thing we want to do is look at this circle that goes all the way around the sphere. The biggest circle that can be drawn on a sphere is called the great circle. That great circle is kind of like the equator of your sphere. It's the biggest circle that can be drawn on your sphere. So when we talk about the radius of a sphere, we're talking about the radius of our great circle. In this case, if the distance from here to here is 5, the radius of our great circle is going to be 5/2. Notice I wrote this as a fraction, not as a decimal. I still have to use my rule of thumb. If I start with a whole number, I want my answer to be in whole numbers, not decimals. So to figure out my surface area, I'm going to take 4 times pi times radius squared. So I have 4 times pi times 5/2 squared. Notice that I put 5/2 in parentheses. That means when I take 5/2 squared, I need to distribute this squared over division. So I have 5 squared, which is 25, over 2 squared, which is 4. Put everything over 1, and I can do this multiplication in my head. 4 in the numerator, 4 in the denominator. The surface area of this sphere is 25 pi. And that's going to be in units squared for area. The volume of my sphere is going to be 4/3 times pi times my radius cubed. So I'm going to have 4/3 times pi times, again I'm going to put 5/2 in parentheses and cube it. I have a power, an exponent with a grouping symbol, and division, which means I can distribute that power to my numerator and to my denominator. So I'm left with 5 cubed. Well, 5 cubed is 5 times 5 times 5, which is 25 times 5, which is just like having 5 quarters. If I have 5 quarters, I have $1.25. So 5 cubed is 125. And 2 cubed, 2 to the 3rd power, is 2 times 2 times 2, which is 4 times 2, which is 8. Make everything into a fraction, and I can actually do this math in my head. 4 in the numerator, 8 in the denominator, simplifies down to 1/2. And now I can multiply straight across. 125 pi divided by 6. And that's going to be units cubed for my volume.